Good morning, everybody, and welcome to Elemental's webinar on decarbonising schools. Apologies for the slightly late start. We have had a few technical issues this morning, and you'll see why in a moment. So, schools. Given the way they're used and occupied, their buildings present a number of particular challenges when it comes to decarbonisation. Yet, at the same time, energy costs are rising, and there's increasing pressure on schools to decarbonise their operations. So today, we're joined by Rob Smelt, who's the Director of Low Carbon Energy Efficiency HVAC company BREng Hull, which has more than 30 years' experience in the building services industry. Rob is going to give us a presentation outlining BREng's key lessons on decarbonisation in schools. We'll be looking at the effects of temperature, heating audits, technologies and controls, and afterwards we'll have a Q&A. So please do drop your questions into the Q&A box below. So, as a result of the technical issues, unfortunately, you won't be able to see Rob, but you will be able to hear him, and he'll be ready to answer your questions at the end of his presentation. So, Rob, thanks very much for joining us today, and I'll hand over to you for your presentation.
Thank you, Rachel. Morning, everybody. The idea of today's presentation is more to give everybody a high-level overview of what we can do with the school building infrastructure to start decarbonising ahead of the goal of the 2030 and the 2050 government plans. So the presentation will walk you through some high-level elements. Don't want to get into too much detail because it can become very complex. So what is decarbonisation? Well, the idea is to eliminate the use of gas, oil and coal in our schools by using the fossil fuels and transferring across to electrically driven heating systems, which will use electric generated by renewables. And that's the whole idea of being able to become carbon neutral, is becoming more electrified using renewable energy. So everybody goes, what's the silver bullet for my school? What can I do to make it carbon neutral? There is no silver bullet. You have to look at every school in its own merit, understand the complexities of the building, then arrive at a solution. So what we look at is when we're looking at schools for companies and for obviously that we work with, and also the school themselves, we look at two goals. First one is we want to reduce carbon emissions, but the second thing is we also want to reduce the running costs. Because what we've noticed in the past is when people have tried to apply carbon neutral technology to schools, the running costs have increased, which is not really the benefit of the school. So what we have to look at is when we look at a school at the moment, which is the most important for that school, is it the running cost or is it the carbon emissions? Because it's more of a seesaw at the moment. But the lower you go on carbon emissions, you tend to find you could be having a high running cost compared to gas. So this is what we're faced with at the moment, taken from the government website recently. We are paying 10.2 pence per kilowatt hour for gas, and we're paying 3 times that in electric. Carbon factors are very similar at the moment. The electric carbon factor has come down because of the blend of renewables that are being used. But then we start to look at the typical efficiencies of your heat generating equipment. Now, when you look at an old boiler, typically it's got an efficiency of 80%. New boilers are obviously more highly efficient. And then you get into the heat pumps. Now, that 380% is an efficiency factor used when it's being used at its best efficient, most controlled delivery of hot water. What you will find with heat pumps is people try to use them like boilers. So what you have to be careful is that 380% can actually in fact drop to only 200%, and that isn't of any benefit for anybody in a school. And then you go on to the next level of heat pumps, which is called VRF, and that has an even higher efficiency. So if we compare typically the running costs, this is where we're looking at it. A gas boiler with a 300 kilowatt output would cost about £33 an hour to run at its full 100%. If you converted that to an air to water heat pump, when it's running at its most efficient, in mild conditions, designed and sized properly, your running costs will actually be lower than the gas boiler based on its efficiency and based on the tariff. If you don't use the heat pump properly and you drop the efficiency, it will in fact cost you more to run. So that's why it's important to ensure that when you're applying an air to water technology to a school, it's done correctly, otherwise it will cost a lot more to run. But if we compare the capital costs, this is also important for a school. The initial outlay for a 120 kilowatt boiler is £7,500. If you compare that to an air to water heat pump, which is 25, a ground source, which is 21, but then you have to add boreholes for the source on it, usually boreholes, that adds another 120,000. So we've got to look at what is the cost of going carbon neutral and how do we achieve it using the best economies of the equipment we choose. So first we would look at is where are we going to heat? Where are we going to heat? Is it a new building or is it an existing building? So new buildings, they're thermally superior. The heat loss is minimal and heat is retained. But because the heat is retained, that also causes issues of overheating. What we found in these type of environments, a VRF heat recovery system is your best option. What that does is it improves its efficiency because you link a system together. So some rooms might need heating, some rooms might be really warm and need a bit of cooling. When we talk about cooling, what we'd say is you don't set your cooling system to cool to 23 degrees. Set it to stop it from overheating. So set your high limit of your room to about 26 degrees. Now in the summer, 26 degrees doesn't feel that warm compared to an outside temperature of 30 to 35 degrees. If you have a temperature in the school lower than 26 degrees in the summer, what you'll find is when you're going out, you'll feel really, really hot. When you come in, you will actually feel really, really cold because of the temperature difference. So what we suggest is, if you put a VRF air conditioning system in, you don't use it to cool, you use it to heat, but use it to harvest energy at certain times of the year from the warm parts of the school and use it in the colder parts of the school. And that reduces your energy consumption considerably. The challenge now is faced in existing buildings. Now these are generally thermally poorer. The heat loss is obviously higher and less heat is retained, but that also is a benefit because it reduces the issues of overheating. The question we always get asked is the sequence of what do you do? Well, it depends on the age of the building. Some jobs we go to, the actual glazing's never been changed from single to double, so we're still working with single glaze. Other times we find that the existing heating system has been sized to work with single glazing, but they've gone and done the double glazing improvements already. Has the roof been insulated? Does it need insulating? So we would look at making sure that the thermal properties of the building have actually been improved from its initial build to reduce the amount of energy that we're using. To generate, obviously reduces the air source heat pump plant that we need to run, and it also reduces the length of time that we need to run it. We also look at what's the existing system, what's the condition of it. So we've looked at some jobs in the past where the infrastructure's about 10 years old. The SIBSI recommend that radiators and infrastructure should last between 20 and 40 years, realistically. So is the infrastructure good enough to reuse? If so, we then look at what boiler plant do we need to change. Without going into too much detail, which we'll cover in a few more slides, you look at the age of the plant. If the plant is quite new and the infrastructure is quite old, you can actually start decarbonising by doing a sequence of renewing the infrastructure in the building, but allow it to run at a lower temperature, ready for heat pumps. But running at a lower temperature allows you to reduce carbon at that point. So looking at an existing building, you've got various things we need to look at. It's the radiant heating for a hall, it's warm air heating for corridors and classrooms, You might have the old style fan convectors, old style radiators. So we do an audit on what you've got, what is the output we need now, not what it was when it was first designed. Does that need to be changed, or does it need to be just increased? This will give you an example. Pre-1990s, a heating system was designed on a flow and return temperature of 1870, and that gave you a temperature difference between the radiator and the room. If you then come along and put an air to water heat pump on, now that heat pump, realistically, you can generate 65 degrees flow, get a 55-degree return, so it'll work at the same designed flow amount because it works on that temperature difference. But the radiator might not be big enough because it's not as hot. So the audit we do, or you should do, is the consultant should come round, look at the school, look at what the current properties are, and check does that radiator match its current demand. If it matches its current demand, you can put an air to water heat pump on without any issue, because that existing heating system starts for that that design of that heat pump. Back in 2000s, everybody started changing the temperature differences on the heating system. Now this causes us so not concern, but it causes us a different challenge. So they worked at a different temperature difference, and because they worked at a different temperature difference, the pipework became smaller. So that worked at a 20 degrees temperature difference. And when we go to air-to-water heat pumps to use the existing infrastructure, what we found is we're working on a 10-degree difference. So technically, the pipework is actually half the size we really need it to deliver what we need. But again, a true audit of the school will determine what is the actual output of that radiator required for that current mode, not when it was first installed. Is that pipework suitable for reuse, or do we need to reuse it? What you would generally find is once the thermal improvements have been made, that radiator or heat emitter will probably be big enough to heat that room. But it's the actual pipework to that radiator that may need changing. Then we get on to hot water. You have to look at hot water completely differently if you're going to go from the current way we do things, which is a big gas-fired water heater, where you can leave your tap running all day and it just keeps replenishing that hot water. So one of the things we need to look at in heating, but especially in hot water, is how do we use the hot water in school? If you're running on heat pumps, you have to have a big storage cylinder to hold your hot water, which is good, but it's also bad because once you've run out of that hot water, you've got to wait a period before the hot water can be replenished, unlike the gas-fired water heaters, which can recover in 10 minutes. So we have to re-educate ourselves on how to use the hot water, how to switch the taps off when we don't really need to use them in a kitchen. So we're not just running taps for the sake of running them because we've never had to worry about it. When we move on to existing schools, which we've actually had some experience with, we look at the existing heating infrastructure, and before we started to look at becoming a carbon reduction scheme, we were looking at the best way of installing new systems, and we arrived at a solution which was the opposite way around that the school was currently being heated. So all the schools seem to be heated with low-level radiators and fan convectors. But in order to install the new system, we looked at, well, what happens if we install something at high level? Then we can install a whole new system before we take the old one out, and then we don't have any loss of heating performance. That then drove us down this route of finding a product that will actually be a really good product for a school to use, because you can use it on an existing heating system, but it's also suitable for working at the lower water temperatures that an air-to-water heat pump works on. So we thought, well, it doesn't cost any more money to do the heating infrastructure change using this equipment, but then it future-proofs it later on for people to convert to air-to-water heat pumps if they so wish. The other benefit of using this on a standard heating system is you can actually reduce the water temperature that your boilers are actually generating. And by reducing the water temperature, you prolong the life of the boiler, but you reduce your carbon footprint every morning you switch your boilers on. Because what you're doing is you're shaking the water up to 55 degrees rather than up to 80 degrees. And that 25 degrees of energy you've not used does save quite a lot of energy. So if we look at a typical 300 kilowatt school, if we didn't heat that water up to 80 degrees and only took it up to 55, kilowatt hours saved would be 104 kilowatt hours in that day. And that would be repeated every day, switch your boiler system on. Then we also look at the carbon saved. We save 21 kilograms of carbon every time we switch that heating system on in the morning. So by just changing your heating infrastructure to start with, doing it the right way around, you are actually saving carbon and energy before you've even looked at the air-to-water heat pumps. Now, this is the challenge everybody's going to face with going to air-to-water heat pumps. This is a school we did, which is quite a large school in Leeds, and there's 12 air-to-water heat pumps down on the bottom right-hand side. Now, each one of those is 2 meters by 2 meters. And that's the amount of space we need to generate the same amount of energy that was already located in an internal plant room, which is obviously arrowed on this screen down to the middle. So you've got to find a suitable location to put all the air-to-water heat pumps. Generally, they won't go on the roof because they're too heavy. So you have to find somewhere around the perimeter of the school. But then you've also got to find a way of getting the pipework back into the school if you're going to reuse the existing heating infrastructure. And that's it, Rachel. Yeah, that's the end of the presentation.
Great, thank you very much, Rob. Okay, everybody, so just a reminder that there is the Q&A box below. Please do drop in a question if you have one for Rob. That was a great presentation, Rob, thanks. I've taken a few notes and there are a few things that I'd like to chat about whilst everyone else leaves their questions. The first is something that's actually happening in the chat here. We're having a conversation about life expectancy for these heat pumps. Somebody says 10 to 15 years seems a bit low. Others have said that that's about on point given the poor level of maintenance at these kinds of sites. Somebody said that they actually do auditing and they find that the quality in a lot of these areas is quite shocking. So what are your thoughts on that?
Well, I would agree with those comments. Your life expectancy of an air-to-water heat pump or any air conditioning unit or any boiler, it really does go down to, I think, firstly, the quality of the manufacturer to start with, but also the quality of the maintenance. I mean, if we all understand cars, so if we buy a really good car, like a BMW or a Mercedes, and we don't look after it, we don't service it regularly, we don't change the oil filter, let the tyres go bald, and we wonder why it doesn't work after 4 years, then we're a fool to ourselves. But likewise, you can buy a cheaper car and you can look after it really well. Make sure the oil's always clean, change the oil filter regularly, always take it in for its service. And that can outlast any good car that's maintained properly. So I think it's a combination of the two. But the third one that people always miss is the original selection has to be right as well. Because if the original selection is done, if it's done based on a contractor choosing it to suit the cost for the school, they may choose smaller equipment that has to work harder for longer, which means it reduces its life expectancy. If you factor in the fact that most of the time it's going to be running at 80%, sometimes it's going to run at 100%, but we can control it so it's not running at 100% all the time, you will prolong the life of the unit. So the 15 years that SIBS recommend, I think it's a general guidance of if you're over 15 years, you're doing well. If you're under 15 years, well, that's kind of because it's not being looked after.
Okay. Question here. Do you think there are enough skilled people out there to carry out the servicing and maintenance of the heat pumps?
In reality, no. In reality, no. I think. Sorry.
I just said, and what do you have any sort of ideas or suggestions about where that trend is going to go, or what's needed to help mitigate the risks associated with it?
I think what we need to do is, because we're talking about schools, we need to look at the education of young people coming through to actually promote more interest in wanting to become engineers and service and maintenance engineers, to create a pathway for them to build the skill gap that basically the construction industry is facing. Not just service and maintenance, but installation, design, management. It's the people coming through that have not got the interest because I don't think they understand it.
Okay. So what are some of the logistical challenges then and practical issues involved in fitting these systems in schools? And I'm thinking that the fact that it might be a bit of a health and safety risk because we've got potentially hundreds, if not thousands, of children running around. So does it then have to be conducted in school holidays? Does that mean that there's a greater demand for this technology in a smaller period of time? What are some of the hands-on issues with delivering this technology in schools specifically?
So in the school specifically, we always used to do, when you've got a heating infrastructure change, you would design it in October, you would price it, you would get someone to do it in the school holidays. Where funding happens now, it doesn't occur like that, so it's very cyclical. So you could actually start doing the project in October. But going back to some of my earlier slides where I said about the new infrastructure and using this high level approach, we went down that road because we couldn't wait to the school holidays to do what we needed to do. We couldn't take the heating system out because we needed the heating system to work while we were installing a new one. A lot of the schemes we do approach this, we'll install everything at high level, we'll use the corridors as a means through, we work with schools and say, can we have 2 classrooms at a time to work in? But we do it out of hours. So the contractor works out of hours doing it outside the school working hours. But having those 2 classrooms free to work in allows them more productivity. So they don't have to tidy up every night and move the desks every night when they come back in. So it gives them that productivity, but we're not working in the school during the school hours.
Okay. Another question here. What about funding for these projects? You've mentioned cutting running costs, but what are the upfront costs? Who's paying for them? And also, what kind of assistance is there for schools that are looking to pursue this?
Right. So I work in a collaboration with a project manager. That project manager looks for funding for schools and also an electrical engineer. So we work as a team on these projects. So Graham I work with is really good at getting funding, and there are 2 streams of funding for schools. One is the SIF bid, which is Continuous Improvement Fund. So if you've got a heating system that's failing, you can apply for it. You can get funding for it through that tranche of awards, and allows you to change the heating infrastructure. Now we've done various jobs at the moment on the SIF bid, but we've changed it to a low carbon scheme. Because the criteria for the SIF bid is just changing the heating system for a new heating system. The next one is called the PSDS fund. So it's a public sector decarbonisation scheme. Now that purely only funds schools and public buildings that want to change from gas-fired heating systems to low carbon. They also fund PV. So if you're doing air-to-water heat pumps, I don't know if you can see on this picture on this school, there is PV on the roof. So they're offsetting some of the electrical costs by putting PV on. But instead of going down this philosophy of if we put a load of PV on the roof, it'll be enough to drive the heat pumps, we need more energy for the heat pumps in winter when there's less energy from the PV. However, they're taking it as an annual offset and going, well, actually, during the summer, we're not in, that generates the most electric, we just export it to the grid. We don't get as much as if we keep it for ourselves, but it kind of helps us offset the carbon production and also the cost.
Okay. Question for myself here. Schools are meant to be used as, well, they're very versatile buildings. Just because a room is a classroom today doesn't mean it's going to be a classroom tomorrow. You did touch a little bit on, heat and cooling, reversing in the systems, but how can we ensure that these systems are able to adapt to sort of new and different demands over time? And I suppose a lot of that comes into the idea of future proofing as well.
Well, what we try and do is obviously if we go back to that slide where I said we change the infrastructure for these new units. So these new units to work on low temperature heat pump systems, they're also cooling units as well. So we've looked at, right, we've got a unit that we can use for cooling and we can use for heating, but primarily we want it for heating, and it's a good output for low temperatures. When you get air-to-water heat pumps, you get air-to-water heat pump chillers. So they not only do heating, they also do cooling. So you have got the ability to look at a scheme and go, well, I've got a school. This school we're looking at now is a really big academy. What happens if it was changed into offices for some bizarre reason? Well, the infrastructure would already be there with these new fan coils, and the heat pumps, you could change some of them to cooling. You wouldn't have to change all of them to cooling. You could do a blended system. So if you think about what the future could hold with the water-based systems, that is possible when we put in the newer fan coils. And when you go to the VRF type system, we size it on heating only with the ability to trim cool it. If we thought the school was going to need more cooling, we would add more cooling. So IT rooms, we size the units on cooling and not heating because they have a greater cooling demand. So we try and think about what might happen in the future, but we also try and think about, well, we don't want the schools or the offices to become an ice box in the summer. So we don't try and overdo the cooling loads.
Okay. There's lots of great chat happening here. People sort of discussing the pros and cons. We've got great comment about the lack of interest in the industry as a career for young people. So everyone, if you do have a question, please do pop it in the Q&A box. Rob, my question for you is, are you seeing a lot of activity in this area for schools? Is the case studies that you've brought up here, are they an exception or to the rule in terms of schools actually moving towards these technologies?
No, I think, in fairness, everybody in schools wants to move to this new way of doing things. Problem is, we've got a couple of case studies, and they've worked out very well. And we always like to do follow-ups to ask. We've done calculations to say you'll reduce your carbon emission, you reduce your kilowatt hours, and we've done a follow-up on one of them at Kepler and just asked, what's your bills like compared to this time 12 months ago? So they've come back and said in March, they've compared March, and they've saved 2,300 kilowatt hours in March just by changing the infrastructure, not the boilers, but just how they run them. And that's a lot of energy to save in 1 month just by changing the infrastructure. But I think you also get other schools that get burnt by wrong application of heat pumps, not understanding the difference in temperature. So they think they're getting a really good system and it doesn't work properly. So there is a mixed bag. If an air source heat pump's applied properly and you've looked at all the pros and cons and you've sized it correctly, that's great, it'll work. If it's not done properly, you'll have a nightmare.
Sure.
Just to touch on this, I was going to say, just to touch on this, what doesn't help is every air conditioning unit and air-to-water heat pump is always published at a certain condition of 7 degrees ambient. So when everybody looks in the book and says, well, I've got 80 kilowatts of air source heat pump, that's at 7 degrees, which isn't this climate. We size at -5, and at -5, that 80 kilowatts becomes about 50. And little errors are, some people pick 80 kilowatt units thinking, 80 kilowatt boiler, I'll get the 80 kilowatt heat pump, in it goes, and they wonder why it struggles, and they wonder why they can't get to temperature. It's because not enough thought's gone at the beginning of what do I actually need.
Sure. Okay, Rob. Well, if we don't have any more questions from the audience, then I think we'll wrap it up for today. Thank you everybody for joining us, and I've really enjoyed this. Been some really great chat there from members of the audience. So thanks everyone for joining us, and thanks again to Rob for this insightful look at decarbonisation in schools. This webinar will shortly be available on our website, and if you're not already following us on LinkedIn, we are Elemental UK, so please do follow us for all of our latest news and updates. Thank you everyone for watching, and have a great day.
Thank you very much.